Hello and welcome to SudoKanard. I have the pleasure of test solving a puzzle that was set by my friend Erwan de la Motte Beuvron, also known as Gelb1n or whatever it's supposed to be pronounced. So this Sudoku is called the real longest arrow. There's been a kind of contest of the longest arrow Sudoku, and I think this one will definitely be unbeatable. Okay, so what are the rules? This three-digit number is the sum of all digits along the arrow, meaning all other digits in the puzzle, in the grid. And there's something with red cells and white cells. So, along the arrow, these red cells have the property that the digit here is either bigger than both its neighbors along the arrow, meaning, or smaller than both neighbors. And all white cells have the opposite property, meaning that one neighbor is bigger and one neighbor is smaller. And I guess that this one has the same property with those both neighbors. Well, we'll see in due time, and this one only has one neighbor. Well, we'll see along the way. That's maybe the rules will need some precision. So let's start with this three-digit numbers. First thing first, the sum of all digits in the grid is 405. So this three-digit number must be 405 minus those three digits. That's interesting. Well, some arithmetic is telling me that this digit should be a multiple of 9, because let's say those cells are A, B, and C. Then this number is actually 100 times A plus 10 times B plus C. And this plus A plus B plus C must equal 405. And if we do some modular arithmetic, meaning we get rid of all numbers that are obvious multiple of 9, what remains, if we subtract 99 times A and we subtract 9 times B, what remains is 2 times A plus B plus C. And this is supposed to be a multiple of 9, therefore A plus B plus C must be a multiple of 9. Well, if you're not acquainted with modular arithmetics, then I'm sorry, and you'd have to trust me. So those three digits we know must have a sum multiple of 9, and the first digit must be 3, because obviously the sum of all three digits will be more than 5, and it will be less than 106. Definitely. So now, what are the possibilities? We have 315, but no, 351, 342, 324. Those ones are impossible, because if you add 3 digits, you won't get anywhere near 400. So perhaps 300. So the sum of all digits should not be 9, but rather 18. So the possibilities are those, but this minus 18 is 387, and this works. So that's the only possible sum. Now, what happens next? How do you do that? The only other information is this weird rule. Oh, is there something about 1s and 9s? I guess there is. 1 and 9 will always be in red because 1 has to be smaller than both neighboring digits and 9 always has to be bigger. So 1 and 9 must always be in red cells. So in this box, 1 and 9 are next to each other here. That's the only place. Oh, so 1 and 9 in this box must be in red cells. They can't be in both cells because it would contradict this pencil mark. So 1 or 9 is in here, and the other one must be somewhere in those cells. So well, on this row, there must be 1 or 9 here. What I'm wondering, if there has to be 1 here, 1 or 9 here, how do you get a second 1 or 9 in here? Or perhaps there's 1 here. Yes, there has to be a second 1 or 9. In this box, it has to be here or there, so there can't be 1 or 9 here. So I think this digit is not counted as having to obey the rule. So there should be 1 or 9 here. I guess. So I guess the rules will need some refinement. Well, it will, because this cell is not concerned by the rule. I guess that's the only possible way of having all red cells obeying the rules elsewhere in here. So those are not red cells. Oh, sorry, those are not 1 or 9. So what should I do? Should I just focus on 1s and 9s? Like in a sandwich Sudoku? Oh yes, I think that's it. Because this is not 1 or 9. On this column, those must be 1 or 9. Oh, unless this has the same issue as this. In which case, it can't be deduced. Oh. Well, I won't make the deduction because this could be the same as, this could follow the same pattern as this. Oh, on this row, only 2 red cells, so those are 1 and 9. Oh, but no, there's still this. So I can't be sure. So what about the rest of this first row? the missing digits are 2, 4, 5, 6. Well, any digit fits in this cell, but here they must be in ascending order. Well, if this is 1, then we have this in ascending order, and those in ascending order actually. Oh, I think that's it. You can't have a reversing order. So between two red cells, all digits must be ascending. For example, 1, 2, 4, 5, 7, 8, and then you go the other way. That's it. So, but we don't know if this is a 1 or a 9. And how will we ever know? Oh, this then is a kind of thermometer. From 1 to 9 in some order, and yes, that's it. One of those digits has to be close to this bulb. Those are thermometer bulbs. There's only one digit out of the thermo, and it's here. And as we see, both 8 and 7 are excluded from those cells, so they must be somewhere this way. And on the thermo, so 8 is either out of the thermo or next to the 9. And can't be here, so 8 will be here or there. And this is an... And if 8 is out, then 7 is close to the 9. It can't be here, so this has to be a 9. And that's a 1. That's a 9. And now we can apply thermo rule. Oh, and that's not a 3. So 3 is out of the thermo. This is 5, 6, 7, 8. And now this thermo is increasing because of this 3. And those are among 2, 4, 5, 6. So this is 4, 5, 6, and that is 2. This is 1 or 2. And that's a 9. And this is a 1. Well, which is smaller than both neighbors, but has only one neighbor on the arrow. Now, those must be 4, 3, and 8. So this can't be a 4. This is 3 or 8. Four has to be here or there. Those digits must be 5 and 6. So it should be 5, 6, 7, 8, and 4. No, but 7 can't be here. So it's the other way. 5, 6, and that's a 4, and that's a 3. There's an 8. And then is this 7? 7, 1, 2. In the middle, oh no, this is with the 9. So this is just bigger than this one. So it can't be a 1, because 1 would be red. It can't be a 2, because this would be 1 and it would be red. So this one is 7. That one is 1 or 2. And, well, it's oscillating here. So this is a thermo. This is a decreasing thermo. 6, 5, no, 6, 5 is not available, 4, 3, so it has to be 3, 2, or 1, 6 or 5, 4, 3 or 2. Oh, this could be 3. And this is increasing, so it has to be 7 or 9. And then it decreases. Well, what next? There must be 8 somewhere on this row. Well, not very useful. Actually, red cells are more a problem than a solution. So now we know that this is decreasing. 7, 9 wouldn't fit, so 9. This is at most 7, at most 5, at most 4, at most 3. So this is 3 or 1, 5, 4 or 3, 7, 5 or 4. No, 8 is not available. Oh, so this could not be a 7. This could only be 5 or 4. This could only be 4 or 3. And here, 7 or 5. And then this could almost be any digit. Any digit. Then this gets up and up and down and down and up and down and up and down. Not really useful. Or is it? Up, down, up, down, down, up, down, up, down, down, up, up. Oh, up. And this is at most 6. So at most 6, at most 5, at most 3, at most 2. So this is 1 or 2, 2 or 3, 4 or 5, 5 or 6. That's restricted. And then it goes down. Well, and then up and up. And then down. And then up and up. Oh. Not sure what to deduce from that. But this method of finding out when things are going up or down may be useful for this run, this thermo. Down, up, down, up, down. So this is a decreasing thermo. So this has to be a rather big digit. 1. I said, if this is decreasing, then this is at least 1. This is at least 4 because of those. At least 6, 8, and this can only be 9. So this has to be 9. And it resolves the whole column. That's unexpected. Now it decreases. And we say, what did we say? So this had to be 8 actually. If 1, at least 4, at least 6, at least 8, this has to be an 8. 6 or 7, at least 4, so that's 4 or 5, 6 is not available. 1, 2, 3, 4 in here, not that restricted. Now this goes down, but there's a lot of choice here. Now there's 9 in one of those cells, and 9 has to be in a red cell, so this is a 9. And now this 9 and this 9 say that 9 is somewhere here. It can't be in this white cell, so 9 has to go at the tip of the arrow. 9 has to go in one of those cells. That's a big cell, and that's a big cell as well. So 9 is possible in both cells. By Sudoku, 3 goes here. One, 2, and 6. Oh, 1 goes here by Sudoku. So those are 2 and 6. Well, 2 or 6 have different impacts on this cell. But something is certain. None of those cells can be a 2. Oh, yes, no. That's increasing, so none of those cells can be a 2, so there's a 2 somewhere in those cells. That is increasing, and that can't be a 1, so that can't be a 2, but this could be a 2. And this could be a 2 as well. No, that's not the place to look. Here we have an increasing thermo with 4, 5, and 7. Making this a 6. Now we have 2, 8, and 6. 6 can't go in the middle. Two, 6, or 8. Can this be 6? 6, 8, 2 would work. 2, 8, 6 wouldn't work. What? Oh. No. That's increasing actually. Or is it? Yes. No. This one must be smaller than 4, so it has to be a 2. So that's 6 and 8. Nine goes into one of those cells. But which one? But this is not a 2. Now we know that 2 does not go here. 2 does not go here, so in this column, 2 goes in this cell. Mm-hmm. 9 must go in one of those cells, and both are suitable. Those cells must contain 1, 7, 8. So this is 7 or 8, which is interesting. It means that this has to be 8 or 9. Now this goes up and down. Up, down, up. So this can't be a 1. That's a 1. This is 7 or 8. And notice that 7 and 8 are not in those cells, so there must be another 7 or 8 here. So this is up, down, and then up. Oh, 1 must go here. We're closing in, but 3 is not here. It could be here. It must be here or there, so that's not a 3. That's a 1. Is not here, it has to be here or there. The interesting part is that if 3 is here, then this has to be 1 or 2, because this one is smaller, so this one has to be smaller as well. And that looks perfectly possible. The other 7 or 9 could be here. It could be 7 here. No, it could be 8 here, 7 there. No, that's not possible. If 7 is here, then this has to be 8. So it can't be 7 or 8 here. The other one must be here. And we still need a 3 in the column, so it must be here. 4 is not here, so 4 is in this cell, making this a 5, and 5 or 6 in this cell. To complete this column, we need 2, 3, and 4, because 3 and 4 here we have a 2. So this is a 6, that's a 2, and that's not a 2. This is 3 or 4. This is 7, 8, or 9, and all 3 of them are acceptable for this cell. On this row, we need 5, 7, 8, or 9, and because of this cell contains an 8. So 7, 9, and 5. This goes up, then down, then up. There must be 1, 2, 3, 4 here. Because of 3, 4, this is 1 or 2. That's increasing, then that's decreasing. This is decreasing. This is decreasing with digits between 1 and 4, so this is 3 or 1, and this is 2, and this is 1. That's 4, that's a 3. I think I said something else than what I wrote. So this one is a 3. And now we have we get a 5, a 3, and a 4. There has to be a 6 on this row. It's because of this one. We put the 6 here. That's increasing, so 5 is not in this cell. On this 7th row, it has to be here. We go down, and it's impossible. 1, 2, 5. Going down here is just impossible because of all digits here. So I'm mistaken here. What's wrong? Oh, my mistake was here. Oh, it's so long ago. 2 and 8 were in the... Oh, how long ago? So 2, 6, 8. Oh, it makes things much faster. Oh yes, that will be much faster. On this row, we have a 4, 5, 6 triple, so we need 8 and 9 because of this 8. That's a 9, that's an 8. Here we have a 4, 5 pair, making those 1, 7, and 8. Because of this one, there's 7 or 8 here. Ascending, descending, so this is 8 or 9. Very similar to what we had before. Well, this would obviously be less than 7 or 8, than 7 and 8. What then? So this is still 1, 2, 3, 4, 5. This goes down, then up, then down. So this is decreasing. So this can only be 1 or 2. Then 2, 3, 4. Then 3, 4, or 5. We still need 5, 6, 7, and 9. 5 and 6 here. This can't be a 9, so it has to be a 7. This can't be a 9 either. This can't be a 9, so 9 goes here. We still need 5 and 6, so this is a 6, this is a 5. Turning this into a 2, this into a 6. Then it goes up, so this has to be 7 or 8. So this one is a 9. 2, 7, and 8 here. But this is increasing, so 2 is here, 8 there. That's a 7, that's an 8. Those must be 1 somewhere, but 1 is not here. 2 wouldn't be red, so that's a 1. And this is a 7. This is now decreasing. This can't contain a 1, though, so 1 goes here. And this can only be 6. So that's a 5, that's a 4, that's a 5. Now this is a 2 with 3 and 4, 3 or 4 here. This is not a 5, so this has to be a 2, this has to be a 1. Somehow it looks like former arguments, but now it should be correct, I hope. 5 and 8 here because of this. That's a 5, that's an 8. Yes, it fits. That's a 3 by Sudoku. And this, and now let's put a 7 here, a 2 here, a 3 there, and let's check. All those last digits do the trick. So that's it. Well, that was fun. And I'm afraid this puzzle will be one of a kind. But I'm very proud of my Padawan R1. He's very inventive, I must say. Thanks for watching this video. And see you soon on SudoKanard.